I don't think I've done an intro to something. The reason being is that I spent so much time working out before I could make a single step that I didn't remember to record and photograph a lot of things. So some things I'll be showing later. You might see it in the background, and that's mainly the C pillar. So I'm going to show you what went into a B pillar and wonder why things take so awfully long. I've done a few other jobs in the meantime, but there's many weeks and months into this that I can't. I'm going to show a tiny little bit of it. So this is about creating this B pillar and everything that went into it. So the only thing of the B pillar that's original to the donor vehicle is the inside up to that line there, because above that, as I would have shown earlier, it had a big curved pillar that came in, and mind you also this pillar has been moved after I chopped the floor, and also made upright, dead vertical rather than leaning back. So there's a lot of work's gone into this just to get to this stage, and what I'm covering now is everything that went into just making this simple outside piece. So bear with me, it's a little drawn out, but it's part of the process of building things. Alright, so I'm starting with working out what shape my B pillar has to be. At least I've got something there to know what the width is between the window frames of the front and rear doors. So I've got something to base things off. So that ends up being 155 millimeters, or what's that? That's about 6 3/16, something like that. And the width of the window frame of the front and rear doors, and they're coming in at 75 mil, or just under 3 inches, 5 millimeter gap. So that means that by the time you add your paint layers, basically that'll come down to 4 or probably 3.5 mil, something like that. So you've got to make allowances for that. So I was really tight on in wanting to, between here and where the door frame has to be made, that I wanted not only the window runner has to be in there, but also the width of the door lock, as I was shown in the earlier video, and that's just on 50 mil with the shallower door channel that I've made up here. As you can see, that's why I went for an earlier model car. So, these were for Toyotas and Fords and Holdens of the 60s, and just from Clark Rubber, as I've mentioned previously. So I actually made a test piece up, one that I could fold it, not quite the way I want to have it, because I'd rather be able to have an extra fold that way rather than a corner to corner weld and then have very little control over the distortion there. Anyway, it's a separate subject. So I've got my overall width established, and I know it's 50 mil, which on per door, so it leaves 25 mil plus half of your 5 millimeters there. So you've got to take all that into account. Also, what was the narrowest I could have my B pillar in the center section where the door strikers go, because you have to allow for the material thickness on the inside plus the actual floating nut or nut plate, and they're back to back. So you've got to make sure, and they're 10 mil each, so you've got to have at least 20 mil in between, plus any material thickness. So what I came up with, 30 millimeters, is the minimum I can get in there between that this pillar can be. Alright, next step in making the B pillar is the shape. You can see the curve that it needs a lot more now. So I made this template that when I've got this outside perfectly level, then I've got the 2.5 degrees here in the middle of the window sill to the door sill curve at 2.5 degrees, and the top at negative 0.5 degree this way. So that works out really well. And so this line here will be the outside of the skin. So I will mark that down, and then I've got to mark the depth inwards from here that the seal will sit on the inside of the door skin to the pillar. So it's about 1/2 inch, so I'll put some 1/2 inch tape next to this mark once I take the template off, and then that will be my fold line. And then this part, as you can see the excess here, this will fold that way. So what I'm going to do first though, rather than changing over all the dies for the tipping on the bead roller, I'll make up the other side of the bead pillar here. So I've got the mirror image basically going down, not quite as far as when, because we've got this detail here to work out. So I've got that all set up. I think that's probably what I'll do. And then I've got to, before all this gets welded together, when I've got the two Z shapes basically, I've also got to make sure that I mount the floating nut plate either side for the door locks as well. So there's a lot to go in, and then we haven't even started on what's below here to go around here and pick up the door seal and everything as well. So all that's still got to go, and then from the door seal up around there, and then of course we haven't even looked at the A-pillar yet. So there's a lot involved in something like this. So I'll have to work out the best way of making this. It should be fairly basic. I'll probably take it down to wherever this starts to curve, and I'll cut out that shape there, bead roll that joggle in it for where the seal sits, the pinch weld seal, and then I can put, that's just a vertical fold here, and then it'll have the identical of this just a couple of millimeters closer in, because you can see it's getting closer here. So the widest point of the vehicle is just behind the B pillar about here. So this is coming in a little bit, so I've got to compensate. And if you look at this ABCD, that's because I've got a rising window sill going up, and that's how much it changes between the A pillar here and the B pillar. So you can see how it's gradually getting higher, and the D pillar is shorter because there's not as much difference between here and where the back of the vehicle will be. So every time I move forward, I make sure that here now, this, I've taken the average right in the middle, so it'll come forward a little bit, and then we'll still make sure that from here I'm going to have that rise going all the way up to the top of that, So all these things you've got to take into account, because from the window sill up, the shape doesn't change. But from there down, you can see how it actually will be tucking in more the further I go back. So it's a dynamic shape that's changing, and you've got to make sure that your template is in the correct position each time for every pillar and position along the vehicle. And then you've got the curve this way as well to deal with in the other direction, which is what this is representing. And that's, don't forget, that's going up and following that curve as well. So there's a lot to keep in mind every time you make something fit into a position. Alright, I've started rolling that arc. So I've passed it through here the first time with just gentle pressure, and it's more just to break the grain, was the right way to say it. just to get the start of it, and then I've done one more pass since while twisting this up as it passes through, because you can't just force your way into that groove by putting more and more pressure, because you end up with a V down and V out, and you'll have big grooves all the way each side, and I'll still get a little. So what I'm going to do now is I'll take that bottom die off, turn it around, and you can see where it often rides on this side, and then this will just sit against the flat, and then I'll pull up against there like that. Yeah, I don't know if you can hear this. I sort of precariously set up the camera just in case there's some interest in how this works. But as it's passing through here, I'm pulling up, so I'm twisting this, because this is just my leverage point. So you've got to keep tension while guiding it through. I don't have variable speed, so when I geared this, it was to do intricate work. But the problem is, it's just too hard to change over a different sprocket with the chain lengths and everything. But at least this will give you an idea of the process. It's not a fast one. But you can see how I'm pulling up this way by levering against the bottom roller, and the top roller is my fulcrum. This is shaking because I'm pulling up that hard. It's hard on the back. Oh. Be a good core strength. And you can see this is the second pass since I last showed it after doing the V. I don't know if you can see, but you can also do it by passing through the English wheel, especially once you've got it set, and you do the same thing. Trick that Peter Tomasini taught me, and many others. So I'm just pushing down, and these are two flat dies. Tends to give a, depending on your bottom die, a softer radius. I hope the camera's focusing on that, but there you go, another method. Another way to do it is to get some, say, 3/4 MDF in that shape, top and bottom, and then hammer this whole ridge over, and that'd be another way of doing it. And or you can even use a solid bar with a groove cut in this depth, and you just turn it all the way along as well. So there's many ways you can do this. Alright, so I've just laid it on there and tipped the edge almost to 90, but if you can see what's happening here, see how it's bowed, and that is because we are tipping on a curve. And if you can see the gap better this way. Really hard to tell. Anyway, there's a good, I would say, 10mm gap through the middle there. It's bowed. So the way to fix that, might be able to see it this way better. You can see that there, into the gap now. So the way to fix that is to shrink this outer edge, and that will push it across this way. And I'll just do that in the simple shrinker stretcher over there. Or if you didn't own something like that, you would have to carefully stretch on this folded edge here, which would do the same thing. It would move it that way. So depending if you're doing it on one side or the other, you always got to think enlarged. If this was a great big disc, and you would stretch the outside because there's more material there than the inside. So, and that's so to reduce that, to flatten that, you have to reduce the amount of material on the outside or increase it on the inside, and that will pull it straight. All right, I'll do that, and then I'll true it up to get it just that last little bit. You can see it's just short of 90 degrees at the moment. All right, just thought I'd show it again. So it was just a single pass through the shrinker, and it moved very easily. Now, and then to get the rest of the 90 degrees, this is an old wood splitter. Well, yes, a wood splitter that I ground the head on. You can see where the handle used to go through here for cutting firewood, splitting firewood, not cutting firewood, splitting firewood. So I just hold it on the edge there and then hit it with my flipper, just to bring it around the last bit, and I just move it along as I hit along the side there, and till it pulls over. So you can now see the curve it's got on the outside. You can see that fairly clearly, sort of. Anyway, so the next thing is I've left this slightly long, and so that will probably upset, once I cut it, it'll actually shrink a little bit too from the heat of the cutting disc. Or if you're using tin snip, it'll actually stretch it slightly and move it the other way. So you're going to have to work it regardless. Probably a jigsaw will be one of the things that you could use, but I often just pass it through the flat wheels of the wheeling machine just to settle everything down afterwards. Anyway, so what I'm going to do, I know I need 30mm from the back of this to the other side by the time the other one comes up and meets it. So I will just use this jig that I made when I was still in the sheet metal trade many years ago. That's a drill bit that's held in with a grub screw in some key stock stainless steel shaft, and I'll just set the depth and then scribe along 15mm, so the total width will be 30 by the time it's welded together, the two halves, and that'll be done. So what I'll do now is I'll probably start on this one, do the same thing. So I've already hung the template on there, so the outside of the template was perfectly level. That gives me, this is going to be where the skin line will be, so the outside of the door. And as you can see, I've made a little mark plus ½ an inch that way. So I'll just make a ½ inch mark there and there, put the template back on again when it's just on the bench, re-scribe a mark along the template, and then I'm doing from that mark outwards 3/4 of an inch to give me that little bit of extra room, because I do find that when you're tipping a flange, if possible, have an even width to the flange, and it'll tip more evenly rather than this in and out, because I'm going to cut it off anyway. So that's what I'll be doing next. Right, this is the first fit up. So I've just clamped the two in. It's the first time I've had either on there since I've done this fold. And wow, I'm not trying to blow my own trumpet here, but that's pretty good going. Look at that. I've just got just here, you can see just the less than a material thickness, and this is only 1.2 mil or 18 gauge. It's just coming out here, so it is slightly under square. So I'll just give it a few taps along here, and the rest is really good. Alright, I've just quickly welded the two together, and what I want to show is that I'm trying, I think, what do they call it now? A TIG torch? No, that's not right. TIG pen, that's it, TIG pen. So this brand here is Sonnleer, so S-O-N-N-L-E-R. And you just feed your filler wire, in this case 1.2 millimeter MIG wire. You just feed it through, and then there's a wheel on the back with two little rubber O-rings on it, and it even comes with extra ones. And because it's always awkward when you're in heavy gloves like I use here against the heat, and this is what I wear constantly anyway, to feed such thin wire. But look at this. Oh, look at that. Just feeds it straight out. You just run your finger across the wheel, it grips the thing, and so all the way along here I did that whole length with only one stop, and that was mainly to move the board in my position, not because I ran out of filler wire, because I can make that filler wire as long as I want. I just I usually cut them off in one curl length, so I wind one lot off the reel and then cut it. So yeah, anyway, it works brilliantly. You know, I was just literally holding it like this and feeding it, obviously with a much shorter tip. I was just feeding it along right in front of the pool, and just just with my finger, feeding it through. And it worked really well, considering this is the first time I've ever done it. There's many varieties out there. I chose this one because it was one of the bigger ones, and it's all machined, I'd say, aluminium, and it makes it easier to hold. I've got very big hands, you know, double XL gloves if I can find them. So yeah, I just thought I'd pass it along. It fits really well. So you can see there, that one weld Sev 3 was a good move. Very pleased with that. You might be able to see the curve a lot more, that gentle curve. It gets, the bottom half is stronger, and then it flattens out above the window line. So this line here represents the window line, so that's how high the window is. I'll see if I can change hands. So if I put this level, you can see it's only just going in at the top. It should only be half a degree in, and 2.5 degrees it goes out of the bottom. And that's what I mean by that, is when it's 2.5 degrees off vertical here, and it becomes level, and then it tapers back in half a degree, and it used to taper out a degree instead. So basically it went out this way and never leveled up at any time. So this, I think, is just a much better shape than a upside down wedge. It just looks weird.